I'm Mike from St. Thomas Economic Development, here with another little update from the St. Thomas megasite. Okay, Finn, good morning, at least good morning in Canada. I think it's early afternoon in Germany, is that right?
It is. It's 1 p.m. right now.
Great. Well, listen, this week we're joined by Finn from PowerCo. Finn, we were on the site a couple weeks ago. So we're on the site today with Finn from PowerCo. It was a windy day, and Graydon was on vacation, and so the wind ruined the audio from that. So we need to talk to you again and get some information about what was going on the site that day. So just to start off, can you introduce yourself and tell us what you do for PowerCo?
Yeah, sure. I can do that. So my name is Finn Weinkötz. I'm working for PowerCo since November of 2022, and I am the senior construction manager for the Standard Factory St. Thomas project, and I am also the geotechnical expert. And that's why we're here today, and that's will be the topic for this interview.
Okay. Yeah, and when we were on the site, we were standing in front of a big drilling rig, and they were doing some geotech samples. But what was significant about that day? Because it wasn't just any old drilling rig.
Yeah, it was a very exciting day for us because it was actually the first drilling of our detailed geotech campaign. So what we were looking at is an SBT drilling rig, standard penetration test, and they are doing geotechnical investigations on our site up to a depth of 50 meters, doing resistivity tests and also collecting soil samples for laboratory investigations afterwards.
Cool. So how does that machine work? How does it actually get the samples out of the ground?
The machine can work in basically two operation modes. One is by rotary drilling. Rotating a steel device into the ground through rocks or stiffer soils that wants to be investigated. And the other mode is a hammering motion with a weight that is falling on top of a device and ramming a sound into the ground. That is more prone for sands and loams, clays, these type of soils.
Okay. Which type were we seeing on the site when we were there?
When we were there, if I recall correctly, we were about 8 meters deep, and we were looking at till materials, so kind of a loamy situation, a mixture of sand, silt, and clay with a rather high clay content.
Okay. What's the importance of these tests? Like, why do you have to do them, and why do you have to do so many of them?
So first of all, by law, we have to produce some information on the ground, very detailed actually, to get a positive feedback for our building permissions. So without geotechnical investigations, we can't apply for one, or we will not be able to execute our buildings. But on the other hand, a very in-depth knowledge about the soil conditions help us to do a bespoke foundation approach. Therefore, we can save a lot of money. A rule of thumb for a standard building would be that around 1/3 of the money is actually below ground surface, so in foundations. In our case, it's a little less because of the intricacy of our project and the very expensive equipment for battery cell manufacturing processes.
Mm-hmm. So when we were on the site, we actually got a chance to take some of the samples and kind of play around with them. And we were trying to identify the different components of the soil. Can you tell us a bit about like what the different components of the soil were that we were testing for?
Yeah, so what we did, we took soils in our hand, and there are specific testing methods to get a first idea of the soil behavior and the soil composition while you're out in the field, without a laboratory at hand. And we were looking basically for the four main categories of soil components. One is a gravel, everything with a grain size above 2 millimeters, not that common in the soils we were looking at. Then the second component is sand with a grain size smaller than 2 millimeters, but greater than 0.063 millimeters. Then we are looking at silt with a grain size of the aforementioned 0.063 millimeters and 0.002 millimeters. And everything finer than that is considered clay. And these different categories, they aren't just by chance put in these boundaries. It's because of their behavior towards aggregation, forming cavities, and also giving a plasticity to these soils. So with various compositions come different properties for soils. That's why it's so important to know actually what the soils are consisting of, and also in what state they are. So a very loosely accumulated sand has different properties than, for example, a sand-silt mixture that was lying there under 20 meters of soil and maybe even had a glacier of 100-meter thickness or more on top of it, and is very compressed down, over-consolidated.
Mm-hmm. Cool. Now, when we were doing that, we decided to have a little bit of a bet to see who could guess most closely the correct constitution of the soil. And so I've got the numbers here. I'll just read them out again.
Oh,
So your
I
guess,
feared that you got them.
your guess, silt, clay, sand was 50% silt, 45% clay, and 5% sand. And because you're the expert, I decided to bracket you with my guessing. And so I guessed that we were 51% silt, 44% clay, and 5% sand. Do we have the results back from these tests yet, or are we still waiting?
We're still waiting on those, but after we left the site, I took a closer look into the sand department, and sand is a very tricky one because we have a lot of fine sands that is very closely resembling the silt composition. So I'm not so sure if we are actually on track with our 5% sand gases. But I will keep you updated. I'm still true to my bet.
That sounds good. Just so the viewers know, there is a bottle of Coca-Cola on the line here. So these are high stakes. Finn, anyway, thanks so much for making the time to do this interview again. And we look forward to seeing you on the site again next time that you're in St. Thomas, and we'll see what else is going on the site.
Like and subscribe on YouTube for another little update coming soon.